Alright, good morning everyone. Today we're going to go through the e-learning for both Tuesday and Wednesday or Thursday, depending on when your block period is. For Tuesday, today, we are going to be working on simplifying radicals, a review of algebra, but something that I saw from talking to you guys about that Pythagorean theorem work is that you guys need a little review of. So, right over here on the left, I wrote down a list of perfect squares. I started at 2 because 1's not going to be helpful. So 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, all the way down to 10 squared. And this could go on. I could do 11 squared equals 121, 12 squared equals 144, and keep going as far as we want. But these are going to be the biggest ones that you're going to run into. So that's what I wrote. Now, to simplify a square root, like the square root of 50, first thing we do is check, is 50 a perfect square? Is there any number times itself that gives you exactly 50? And the answer is no, not really, because right here we have 49 jumps to 64. 50 is somewhere in between, so it's going to be somewhere between 7 and 8, some decimal, but we don't know what that decimal is. To do it, to simplify this, we need to find a number in this list here that will divide 50 evenly. So we can start on 49. There's no point in looking at numbers bigger than the number you're trying to simplify. So if you do 50 divided by 49, that gives you a decimal. 50 divided by 36, that gives you a decimal. 50 divided by 25, there we go. 50 divided by 25, we get the square root of 25, square root 2. So I'm just breaking 50 apart into two numbers that multiply together to give us 50. Because 25 times 2 is 50, we're in good shape. Now the square root of 25, well, that's 5. That's a perfect square. That one's easy. The square root of 2 doesn't have any perfect square factors, so it's stuck under the radical. 5 times the square root of 2. All right, moving on to our next one, the square root of 112. Also would not be in our list. The next one would be 121. So we try 112 divided by 100, decimal, divided by 81, decimal, divided by 64, decimal, divided by 49, decimal, divided by 36, decimal, divided by 25, decimal, divided by 16. I think that one will work out. If we do 112 divided by 16, we get 7. So I can break the square root of 112 to the square root of 16 times the square root of 7. And the square root of 16 is 4, so we have 4 radical 7. Now, if you didn't find 16 right away, there's actually another perfect square factor of it. 112 is divisible by 4. 112 divided by 4 gives us 28. So we could have broken 112 to the square root of 4 times the square root of 28, and we got 2 square root 28, because the square root of 4 is 2. 28 is not a perfect square. This and this are not the same answer. The only problem is here we're not done yet. 28 is divisible by 4. We can do 2, break our 28 apart to 4 and 7. Square root of 4 is 2, so we have 2 times 2 radical 7. 2 times 2 is 4. 4 radical 7. So you get the same answer either way. All right, moving right along to number 3, the square root of 30, not on our list. So we do 30 divided by 25, decimal, 30 divided by 16, decimal, 30 divided by 9, decimal, 30 divided by 4, decimal. This cannot be simplified or reduced at all, so it just stays the square root of 30. Sometimes that happens. For the last two we're going to do, let's look at ones that have a coefficient or a number in front of it. Let's just ignore it for right now and work with the square root of 18. 18 can be divided by 9, so I'm going to break it to 9 and square root of 2. The negative 3 is just dropping down. The square root of 9 is 3. So I have negative 3 times 3 is negative 9 square root 2. So just simplify the radical like we did before, and then multiply that coefficient with the number that's no longer under the radical. Last one, we have 4 times the square root of 76, so my 4 will drop down, and I need to find something that's divides 76. Let's try 16. No. So then let's just try 4. 4 works and leaves us with 19, which has no perfect square factor, so that's as far as it'll go. 76 is broken apart to 4 and 19. The square root of 4 is 2. 4 times 2 is 8. So that's our answer. To make sure that you know this is as far as it can go, 19 can't be divided evenly by 16, 9, or 4, so that's as far simplified as it can go. All right, that's Tuesday's notes. There's a worksheet with about 15 or 16 examples of simplifying. That is what needs to be completed and turned in for your attendance for Tuesday. Now for the block day, we get into section 8.1 here with the geometric mean. A geometric mean comes from solving a proportion. You've talked about the arithmetic mean before, which you've just called the average, where you added up two numbers and divided by 2. So a geometric mean is kind of another way of finding almost an average, but rather than with addition, it's with multiplication. So to find the geometric mean, when we solve this problem, we do a times b equals x squared. Take the square root. I'm going to flip my equation over, but we get x equals the square root of ab. So the geometric mean of two numbers, you multiply them together and then take the square root. To find the geometric mean of two numbers, multiply them with each other and take the square root. So right here, we have two numbers to find the geometric mean. So we multiply them together. 2 times 50 is 100. 2 times 50 is 100. And now I need to take the square root of 100, or 10. So that's our answer. To set that up as a proportion, we have the geometric mean between 2 and 50. When we cross multiply, 2 times 50, and then x squared. So we have 100 equals x squared, square root both sides, square root of 100 is 10. All right, here we go again. Geometric mean, we have x squared equals 3 times 12. We have x equals the square root of 36, or 6. The geometric mean between 3 and 12 is 6. Multiply the two numbers together. 3 times 12 is 36, and take the square root. Now, this is going to come up when we do some proportions here with a right triangle, much like this picture exactly right here, is where that geometric mean comes in. But before we start applying that geometric mean to these types of problems, let's work on just talking about why it works. So this says if an altitude, remember an altitude means it comes down to a right angle, so CD is an altitude, is drawn to the hypotenuse or longest side of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So triangle ADC, this one over here, is similar with the whole triangle and with this little tiny one. I like to call them the big, the whole thing, the medium over here, and small. All right, so they are all similar to each other. All of them are similar. So first, let's work on writing a similarity statement, identifying the three similar triangles. So I have triangle something is similar to triangle something else, is similar to triangle something else. So I need to name my three triangles. If I start with my big triangle first, the whole picture, I'll just do FEG, FEG. So I started on, for the big triangle, I started on the right angle, FEG. So that means for my other two triangles, they need to start on their right angle. If I look at just the middle-sized triangle, it's this one here. The right angle is H, so H has to come first. For the small triangle, this one right here, if this is a 90-degree angle, that means this also has to be a 90-degree angle, so H has to come first in this triangle as well. 90 with 90 with 90, all right? Then I went from the 90 along the short end, which got me to E, from F to E. So when I look at this one here, I go from 90 along the short end, takes me to F. So F will come next, which, if you've already done H and F, that means G has to come last. And then for this one over here, I already did H, go along the short end, takes me to E, and that leaves F as the last one. So that's how we can write our similarity statement. This one right here is just another example of writing similarity statements. I would kind of ignore the multiple choice options. I think it's actually a little harder than just doing it on your own because you might pick a different starting point than they did. So if I work with my whole big triangle, I'll do angle or triangle M along the short side to N to L is similar to triangle. Working with the medium, I need to do right angle is O along the short side to M. Last one is L is similar to triangle. Working just over here, my right angle first is O, short side is N, and then M, so O, N, M. Now to find out where this matches up, they did not name any of theirs that way. So I need to find M in my first triangle with O and O, M with O and O, so that one's still in, M with O and O, B is out because O doesn't match up, M with O and O, that's in, M with O and O, that one's out. All right, then N to M, so that one's out, so it has to be C. Again, you will on tests and things not be doing it with multiple choice, which makes it easier because you just have to write your own statement. All right, now this is where we apply that to our geometric mean idea. And these are both things about geometric means. This one says the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two pieces, x here and y there. The length of the altitude is the geometric mean between the length of these two segments. So h is the geometric mean between those two here. Here, when it's not that altitude, but one of the legs of our big right triangle they give us, we do that the leg, whether it's A or B, it is the geometric mean of that whole hypotenuse and the piece that it touches. So in both of those situations, what we have is a segment going from the right angle of our big triangle. It's either h, the altitude here, or it's one of the legs. So in every situation, you have a segment going from the right angle of the big triangle down to the hypotenuse. So whichever side is going from the right angle of the big triangle down to the hypotenuse, whichever one goes from that right angle down, that's the one that shows up twice. H shows up twice, and it's going down. In this example down here, they're doing it about B shows up twice. Here, A is the one that shows up twice. So the one that goes from the right angle of the big triangle to the hypotenuse, that is the one that will show up twice in your proportion. And then the other two numbers that show up are the two pieces that angle touches for its endpoint, or that side touches for the endpoint. So h comes down, and at the other end, it touches an endpoint of x, and it touches an endpoint of y. So x and y are our other two numbers. Here, b comes down, and it touches an endpoint of x, and it touches an endpoint of the whole thing, so x and c. B comes down and touches one end of x and one end of the whole thing, so x and c. A comes down and touches one end of y, and it touches one end of c, the whole thing, so y and c. Let's work some of these out and see how they go. So here we go. It wants us to find c, d, and e. All right, well, let's start with c. C goes from the right angle of the big triangle to the hypotenuse. So C is going to be the one that shows up twice. And C is the geometric mean of, since C touches this part, 24, and it touches the whole thing, 24 plus 6 is 30. So I have C squared equals 24 times 30, 720. Take the square root of both sides. The square root of 720. This is not a perfect square. It is about 26.8. If we just round it off to one decimal place, that is C. We could, of course, do that in simplest radical form. If we wanted to do that, we could break 720, square root of 720. It can be broken apart to 36 and 20, which would give you 6 radical 20. 20 has a perfect square factor of 4, though, so I can break that apart to 6 radical 4, radical 5. Square root of 4 is 2. 6 times 2 is 12, radical 5. So I should have broken it apart to 144 times 5 right away, but I just didn't catch that. So these two answers are the same thing, a decimal approximation and simplest radical form. But either way, that's C. So we're done with C. Now we have to move on to D. D goes from the right angle of our big triangle down and then touches the hypotenuse here. So D is going to show up twice in our proportion, and those D's have to get multiplied with each other. To finish it, D, this segment here, touches this little tiny piece of 6, so 6 is one of the numbers, and it touches the endpoint of the whole thing, so 24. It never touches just this piece. If you only look at this piece, J is not touching it, but it touches the little tiny one, and it touches the whole thing, so 6 and 30. It does not touch 24. Apologize, 6 and 30. So we do 6 times 30, and we get 180. D squared equals 180. Take the square root. D is equal to 13.4. And you could find that in simplest radical form as well. So that's D. Moving on to E. E is this one right here. E is going from the right angle of our big triangle to the hypotenuse, so E shows up twice, on bottom of our first one, on top of the second one, and the two pieces that E touches are 6 and 24, 6 and 24. E never touches an endpoint of the whole thing. JL, E doesn't touch any of its endpoints. It touches an endpoint of this piece and an endpoint of that piece, but never the whole thing. So we do 6 times 24, and we have E squared equals 144, and that's one of our perfect squares. E is 12. All right, this one is just finding one of the lengths. So E, here's the right angle of our big triangle. E touches 16. And it also touches the whole thing, which is 20. So we have E squared from cross multiplying. 16 times 20 is 320. Take the square root. I have E equals the square root of 320 is 17.9, about. I did round that off. If we didn't want to round it off, I know that 32 is divisible by 16, so I can break it up to 16. 320 divided by 16 gives us 20. So 4 times the square root of 20. 20 has a perfect square factor of 4, 5. 4 times 5 is 20. Square root of 4 is 2. 2 times 4 is 8. 8 radical 5. 8 times the square root of 5 and 17.9 are the same thing. All right. Here's our last example. A jetliner has a wingspan BD of 211 feet. The whole thing is 211. Segment drawn from the front of the plane to the tail, AC, this segment here, intersects BD at point E. It's going to be a right angle. What is the length of the aircraft, the nearest tenth of a foot? They want the whole thing. Well, if we look at just this part right here, we have a right triangle with that drawn in. So we have an altitude drawn in. Here's a right angle. It's a right angle. We know that this side right here is half of 211. 211 divided by 2. This piece here, BE, is 105.5. So we know that this altitude, 105.5, is the one that shows up twice because it goes from the right angle to there. So that shows up twice, is equal to 163 plus whatever EC is. I'll just call that X. So I have 105.5 squared gives me 11130.25 is equal to 163x. Divide by 163, and I find that x is about 68.3. So this is 68.3, so you're tempted to circle A, but it does not ask for EC. It wants the length of the aircraft. So we have to add the 163 for this part back in, and we get about 231.3. 231.3. All right. This is the this is your homework. For this one, I want you to express all square root answers as decimals rounded to the nearest tenth. You got practice of simplifying radicals on the previous worksheet. Let me know if you have any questions. I'm available through email. Have a good day.